Inside the Vehicle Assembly Building at NASA's Kennedy Space Center in Florida, NASA's Space Launch System, SLS, rocket and Orion spacecraft are undergoing integrated testing to verify they are ready for the launch of the Artemis 1 mission by the end of Q1 2022. And on a different front, Stratolaunch's Rock, the world's largest airplane, took to the skies again on Sunday, completing its first test flight in almost 8 months. Rock's proven test envelope was increased during the 4-hour and 23-minute trip, which included a greater altitude as well as retracting and extending one of Rock's main landing gear in flight for the first time. So, what exactly are the updates on these two projects? Hello and welcome back to SPACEX. When will Artemis 1 launch for space? Do you think that Stratolaunch's Rock will achieve its goal of launching hypersonic test vehicles while airborne? In today's video, we look at Artemis 1 and the Stratolaunch's Rock's successful test flight. But, first, before we go on with today's video, a sub to the channel would be very appreciated. Comment, share the video, and don't forget to leave a thumbs up for the video. And without further ado, let's get into it. During the second week of January 2022, engineers and technicians from Artemis I conducted an engineering test series of the SLS rocket core stage within the Vehicle Assembly Building at NASA's Kennedy Space Center as part of the integrated testing prior to launch. A number of tests were conducted after one of the 4-25 rupees engine controllers was replaced so as to ensure the massive core stage was ready to be moved to the launch pad for a wet dress rehearsal before the Artemis I launch. They tested the communication between the flight computers and other core stage components, as well as rotating the engines slightly to replicate the gimbaling they'll experience in flight. In the course of the Artemis I core stage engineering testing, all 4 engine controllers were turned on and verified that they were functioning properly. Once the controllers were switched on, the engineers were able to properly execute diagnostic checks on each one. In order to demonstrate the ground launch software and ground launch sequencer, which checks the vehicle's health and condition while at the launch pad, the crew will have to conduct a second countdown sequencing test later on. The simulated launch countdown checks the reactions of the SLS and Orion spacecraft, as well as ensures that the sequencer is correctly functioning and operating. It will not be until the wet dress rehearsal test has been completed that SLS and Orion will be taken to the launch pad for the first time. In preparation for the Artemis 1 wet dress rehearsal anticipated for late February, engineers and technicians from Exploration Ground Systems retracted and extended the Orion spacecraft crew access arm on January 11th. This was part of continuous work leading up to the Artemis I wet dress rehearsal. It is necessary to move the arm from its retracted position during vehicle assembly and launch pad operations in order to engage with the SLS rocket at the Orion crew hatch location, which allows the Orion crew module to enter and exit from space. During crewed Artemis missions, the access arm also acts as an entrance and departure point for the astronauts aboard the ship. The arm of the Orion spacecraft is retracted just before takeoff. The crew, on the other hand, is still working on the final testing and closeouts of the SLS and Orion spacecraft. The mission is scheduled to launch in 2022. On December 17, the crew conducted an end-to-end communications test to ensure that the rocket, spacecraft, and ground equipment can communicate with the consoles in the launch and mission control centers. When the SLS rocket and Orion spacecraft are tested on radio frequencies, the launch crew can be certain that they will be able to monitor them both on the ground and in flight. In the test, one antenna in the VAB, another near the launch pad that will cover the first few seconds of the launch, and a more powerful antenna that makes use of the tracking data relay satellite and the deep space network were all used in conjunction with one another. In a countdown sequencing test on December 20th, the Exploration Ground Systems team demonstrated the ground launch software and sequencer, which checks the health and condition of the vehicle on the pad, and it was a success. When the launch simulation was completed, SLS and Orion's responses were tested, demonstrating that the sequencing procedure is correct. Around 30 seconds before liftoff, the ground launch sequencer transfers control to the rocket and spacecraft, and an automated launch sequencer takes over. Engineers have built in a second sequencing test before the deployment to account for differences observed between the emulator and the actual flying hardware during the first test. Engineering and technical staff members successfully removed and replaced an engine controller from one of the rocket's 4-25 rupees engines last week after identifying a problem during the rocket's core stage's power-up testing. As part of their routine engine controller diagnostic testing and checkouts, engineers are now responsible for performing tasks such as controller power-up and flight software load. Next, the team will attempt to complete all remaining SLS pre-flight diagnostic testing and hardware closeouts in time for a mid-February deployment and a late February wet dress rehearsal, if possible. A target launch date will be determined once a successful wet dress rehearsal test is conducted by NASA. The SLS will be the world's most powerful rocket, capable of delivering the Orion spacecraft, astronauts, and supplies to the Moon in a single mission. With the Artemis missions, NASA will put the first woman and the first person of color on the Moon, laying the groundwork for long-term exploration in preparation for trips to Mars in the future. The SLS and the Orion spacecraft, as well as the commercial human landing system and the Gateway spacecraft that will orbit the Moon, serve as NASA's backbone for deep space exploration. And on other news, the third test flight of Stratolaunch's enormous aircraft, which was built with the backing of late Seattle entrepreneur Paul Allen, took place on January 16. The flight marked the beginning of a new chapter in the company's 10-year quest to construct a flying launch pad. In terms of wingspan, the Stratolaunch rock aircraft, which has twin fuselages and 6 engines and is named after a fabled gigantic bird, is the world's largest aircraft. It was founded by Allen in 2011 with the objective of using the Rock rocket to launch spacecraft into orbit from the ground. However, following Allen's death in 2018, the company was transferred to new owners, and Rock's primary focus has switched to the development and deployment of hypersonic test vehicles for military and commercial applications. The development program for Stratolaunch's Talon, a hypersonic vehicle, which will be launched from the air and fueled by rockets, may begin testing as early as this year if all goes according to plan. The test flight, which lasted 4 hours and 23 minutes, was conducted from California's Mojave Air and Spaceport. It occurred almost 3 years after Rock's first flight and roughly a year after his second trip, respectively. In addition to evaluating the plane's performance and handling qualities at greater altitudes, the flight included the retracting and extending of the plane's left mid-main landing gear, which was the primary objective. According to Stratolaunch, the Rock reached a maximum altitude of 23,500 feet with an indicated airspeed of 180 knots, exceeding the previous flight test's maximum altitude of 14,000 feet. Before landing, the plane's crew made a couple of close passes to test the landing gear. This successful flight demonstrated and validated advancements to the carrier aircraft's systems and overall flight performance. According to Crever, the partial gear retraction during the test flight was part of Stratolaunch's graduated strategy to establishing trust in the landing gear and gear door hardware. He continued stating that, isolating and testing the left main landing gear in isolation decreased risk while also providing pilots with options for landing the plane if the hardware did not perform as expected. The plane was piloted by Mark Giddings, a senior test pilot, with Evan Thomas serving as co-pilot. Thomas serves as the company's vice president of flight operations, and he was the pilot on Rock's first 2 test flights. Jake Riley, the flight engineer for the crew, was on board for the test flight. NASA's Spaceflight.com webcast host Grace Wong reported that 6 to 8 flight tests were planned in preparation for operational hypersonic launches during a webcast presented by the Stratolaunch design engineering team. The following test flight, according to Stratolaunch's chief technical officer, Daniel Millman, will expand the landing gear envelope, and the pylon for the Talon, a hypersonic test vehicles, will be deployed on the 5th test flight. The Ta-0 and Ta-1 vehicles, which will serve as the first 2 Talon A vehicles, are now in the process of being developed. According to Stratolaunch, the Ta-1 spacecraft successfully completed its initial power-on tests in late December. As a result of Russian and Chinese attempts to develop hypersonic weapons that are capable of evading U.S. defenses, the hypersonic flight has risen to the top of the national security priority list in recent years. Stratolaunch has been given a contract by the Missile Defense Agency to investigate the feasibility of using reusable hypersonic testbeds for defense-related applications. A fixed-site launch system, says Stratolaunch, is less adaptable because it can only operate from an airport with a long enough runway to accommodate the Rock rocket. And that's all for today's video. Thanks for watching. Did you like the video? Will the technology of Stratolaunch be viable? Will Artemis I hit their deadlines? Comment below, let's engage. Also, if you are interested in more videos like this, Make sure you like this video, share and subscribe to our channel. Don't forget to turn on the notification bell for more amazing videos. Goodbye, see you in the next video.